Check. Test, check 1, 2.
Are we ready? Okay, good afternoon. Hello, everybody. We're going to start. So to begin, let me remind you, please, to turn off your connection to wireless so we maintain our connectivity in the classroom. Okay. So today it's my great pleasure to introduce Professor Sheila Olmstead. And Sheila is a professor at the Cornell Brooks School for Public Policy. Before that, she was dean and Dean Russ Chair at the University of Texas and the LBJ School of Public Affairs, and she's been at the school, Yale School of Environment, also serves as a fellow at the Resources for the Future. Among a number of associations, Professor Sheila Olmstead served on U.S. Science Advisory Board at the U.S. EPA and served in the White House as senior economist for energy, environment, and the Presidential Council of Economic Advisors. She studies the economic dimensions of environmental policies, and she's influences thinking and regulatory policies in climate change and water resource management, including the effect of carbon storage on local air pollution, which I think we'll hear about today. So let's welcome Professor Olmstead.
Thanks, Peter, and welcome to everybody here. So as Peter mentioned, I'm an economist by training, but I work in a policy school. So I do applied work, a lot of empirical analysis of the impact of policy A on outcome B and those kinds of questions. And as he mentioned, I also have done public service in a variety of forms, and that's pretty common for faculty members in policy schools. And my last direct public service, in addition to being on the Science Advisory Board for the EPA, which has recently been dissolved and will hopefully be reconstituted at some point, I did serve in the White House starting under President Obama and finishing up under President Trump. So I was there from 2016 to 2017, during a period of dramatic change, not terribly unlike what we're kind of experiencing now. So a lot of my thinking about climate policy and incentives for climate action and so on are informed by that kind of service. And so I'm happy to take questions about those issues as well as we kind of get through the talk. But today, what I want to talk about is a particular set of technologies that are kind of important for achieving both kind of aggressive decarbonization goals within the United States and also on the broader global climate scale. And in particular, I want to talk about point source controls on emissions of carbon dioxide and related gases. So the types of CCUS technologies that I'll be talking about today are those that might be installed on power plants or industrial facilities like refineries, petrochemical facilities, steel plants, and so on, that kind of capture CO2 emissions before they're released to the atmosphere and then bury them in kind of deep geological formations. So that could be saline aquifers. It could, in some cases, involve storage in old oil and gas wells. There are also utilization approaches, and that's going to come up a little bit today. So that's more commonly talked about for something like making green cement, right? Cement or concrete with CO2 embodied in it. I'm not really going to talk much about that. But one type of utilization is also used for enhanced oil recovery, or EOR, and you'll see that come up because the incentives for carbon capture at the federal level in the US are differentiated depending on whether you're using sort of geologic storage that is not for enhanced oil recovery or if you are using it for enhanced oil recovery. So it will come up in that context, but mostly I'm talking about sort of capturing CO2 from a point source and then kind of burying it deep in a geologic formation so that it can't go on to generate climate damages, right, by kind of contributing to the accumulation of CO2 in the upper atmosphere. And so what role have people envisioned this technology or set of technologies playing in global decarbonization efforts? It's actually quite a significant role, particularly for reducing emissions from the industrial sector, and to some degree from power plants as well, although in the United States and in other economies, there are often cheaper and kind of better ways from an economic perspective of reducing CO2 emissions in the power sector than by installing CCUS. But we'll talk a little bit about that today and kind of differentiating between these two sectoral applications. Right now, the scale of deployment of this technology is fairly small. So if you see if I can get the cursor working here. No, okay, well, we'll use this instead. Right, so if you sort of see that, think about the scale of current deployment as being pretty close to what it was in 2023. That's what's depicted in the kind of first row of this graph. This is looking at some data from the International Energy Agency, and so their World Energy Outlook is a really nice place to go to look for data like this. And then they have three different decarbonization scenarios. They're kind of looking at what countries have actually done through the policies that they've implemented and what those policies imply for decarbonization goals in 2035 and 2050. This is sort of like pledges, maybe sort of Paris Agreement pledges, so things that countries have committed to doing but don't necessarily, or some of which they have policies in place to accomplish and some of which obviously they don't because those bars are quite a bit bigger. And then this is more of sort of net zero by, I think, 2050 goal. And that, so you can see as we get increasingly aggressive with our decarbonization goals, you see a larger role for the kind of total amount of sequestration that we would anticipate as kind of least cost approach being carbon capture, point source carbon capture. And then here again, they differentiate by the power sector, by the industrial sector for clean hydrogen, and then direct air capture. And I'm not really talking about direct air capture today. This is, some similar technologies may be used, but that's kind of outside the scope of what I'm talking about today. So you can see as we get more and more aggressive with our goals, we get a kind of greater amount of emissions that we expect. The sort of cheapest way to sequester them would be to use some kind of point source carbon capture approach. And that mostly, at least in the US, we're talking about industrial sector applications, but you can see there's a sort of significant share of power sector applications that show up in the bottom two goals as well, or sets of goals. So a couple of things to notice, right? We definitely need more deployment to meet current policy goals, right? If we think about the Paris Agreement goals, right, as being the goals in question. And then we also think about primary applications on this graph, mostly in the industrial sector, but also some important applications in the power sector too. How about in the United States? So it's a little tough to say right now, right? Our kind of climate policy goals at the federal level are definitely in flux. Another kind of 180-degree pivot that we're experiencing, right, that started at the beginning of this year. And so I think the thing to look at and to kind of keep our eye on is what kinds of projects are in development, where are we with development of this and deployment of this technology. Again, as you saw in that 2023 graph at the global level, the deployment is small, and that's true in the United States as well. But we do actually have more CCUS capacity than really any other individual country, and certainly the majority of planned capacity for this technology, right? Investments that firms have already made and clusters of firms have already made working toward increased deployment. At commercial scale, I account, if you look at the Global CCS Institute, which is a nice place to go for data on this, we look at about 19 projects operating at commercial scale and then many more under development. Again, most of that is in the industrial sector, but I'll be talking about one or two important electrical power generation applications today as well. Okay, so what I want to talk about today mostly is US policy that's designed to incentivize the deployment of this technology. And that primarily, right now, is a federal tax credit under Section 45Q of the Internal Revenue Code. And so this particular federal subsidy is often referred to simply as 45Q for short. And so 45Q in 2025, the kind of most relevant incentive that we'll be talking about today is about $85 per ton of CO2 for what's this sort of geologic storage option. If you store it in a deep geological formation, but you're using it for enhanced oil recovery, then the incentive is somewhat smaller. So instead of $85 per ton, it's $60 per ton. And then if you're using kind of carbon capture in terms of direct air capture, the incentive is much higher. Again, that's a much more costly endeavor, so it makes sense, right? We're trying to incentivize, we give a higher price, right, for something that's more expensive to do. So what I want to show here is if you look at the graph on the left, right, this is something I prepped with several colleagues of mine in a paper that we're working on. And here you can see that that incentive has actually gone up quite steeply for all of these different applications over time. So if we start back with the original incentive creation back in 2015, we were giving firms around $20 per ton for this technology. So every time, right, they capture a ton of CO2 from their flue gases and they put it into a deep underground formation, we're paying about $20 per ton. And then surprisingly, in 2018, we had a law passed by the Congress. There wasn't a whole lot happening. If you take yourself back to 2018, some folks in the room are old enough to think back that far and maybe be policy aware, but we're sort of in the middle of the last Trump administration. The Congress was sort of hogtied in a lot of ways, making progress on any kind of climate legislation, but we did actually enrich the incentive for CO2 capture at that time. And so the incentive went from about $26 per ton to about $50 per ton. And then the really big change that happened recently was the Inflation Reduction Act passed in 2022, raised that incentive starting, kind of this year, next year to about $85 per ton. So we went, kind of 20 to 50 to 85 in a pretty short period of time. And so you could say, well, why talk about this today? This is all likely to change. The Trump administration's talking about repealing many of the incentives that were created under the Inflation Reduction Act. I think that's a very reasonable question. What I would ask us to do is think about how likely that is to change and in what direction, given that this is something that has had bipartisan support and actually tends to favor the oil and gas industry quite significantly relative to other subsidies, right, that are kind of around and maybe more politically vulnerable, right? So it favors the oil and gas industry, which the administration has explicitly stated many, many times and in many, many ways with direct steps that they'd like to do. And also there are benefits that are going to tend to flow to red states. So if I had put the storage capacity on that map along with facilities. In fact, it might even be there. No, not this version. But what you would see is that a lot of that storage capacity is places like the Gulf Coast, right? Places like the upper Midwest and so on, places where we sort of might think of as typically red states or Republican states. And so if we think about what's likely to change, right, there is a repeal proposal in the US House that does have some bipartisan support, and there have been proposals before in that regard to drive the subsidy to zero, right? If it's currently $85 per ton and we repeal, we would drive that to zero. You can see that in this bar over here at the left side of the graph. This is kind of other proposals that have showed up in the Congress over quite, say the last 10 or 15 years. And one of those was Senator Bernie Sanders, who had a policy he proposed to drive the incentive to zero. But others have been, kind of in this range here, between that 50 and, right, or, even above that $50 to $85 per ton that we've seen. So it's hard to say what's going to happen to this particular subsidy or any subsidy, but it's quite different from things like subsidizing renewable power generation and other things that might be more politically vulnerable. Okay. So let's back up for a minute, and I want to think about this subsidy from an economic perspective and some of its upsides and downsides as a climate policy tool. That is, if we're interested in mitigating the emissions that are changing the global climate, is this an approach that we would support versus other approaches to achieve the same goal? And in general, I'm an economist, so I have to say at the beginning that we tend to prefer sticks over carrots, right? So there's lots and lots of reasons for this that I don't have time to get into today, but it's not terribly surprising given that I said that almost 3,700 economists have signed on to a statement by the Climate Leadership Council that proposes a sort of $30 to $40 per ton CO2 tax with a rebate program, right? Sort of the federal government would take this tax in and then redistribute the revenues to individual households kind of at the end of each year, including 4 former chairs of the Federal Reserve, 28 Nobel laureates in economics, and many others. That is just generally kind of our favorite approach to this kind of a problem. And we'll talk about why in just a few minutes. Generally, global carbon pricing is on the move, so this can take the place of or the form of a carbon tax or a cap and trade or an emissions trading system for CO2. Both are ways of kind of putting a price on CO2. And so firms that are emitting CO2 to the atmosphere then have to pay that price in order to emit the CO2. And then they face a choice for each unit that they emit. They can either reduce it, they can engage in some kind of pollution abatement through technology or other means, or they can pay the price, okay? And those kinds of systems, as you can see, are in place in a lot of our major trading partners, including almost the entirety of the EU. So lots of trade with the EU, and the EU has the EU emissions trading system, which is a cap and trade program, and that puts a price on CO2. China, also with which we have lots of trade, has a cap and trade policy that's just a few years old now for carbon dioxide that's targeted toward power plants. You can see we've got carbon pricing in Canada, we've got even in parts of the United States, so the state of California, the state of Washington, right, and a couple others. There's the RGGI kind of CO2, there's a trading program. That's the one that's the kind of mid-Atlantic and northeastern program that you can see highlighted over here. But importantly, the US as a whole doesn't have, right, sort of carbon pricing at the federal level. The last serious attempt to achieve that was during the Obama administration in 2010, when a motion to do this kind of passed out of the Senate, went into the House, and failed in the House at the last second. And so, right, we really haven't seen a serious effort since that time to install carbon pricing at the federal level. Instead, what we have, and especially through the Inflation Reduction Act, which was a President Biden era set of kind of package of policies, is a whole bunch of subsidies that are, kind of technology and sector specific. So while a carbon price says, right, here's the price of emitting CO2 across the economy, and you pick your technology or your approach to reduction, right, if you are incentivized to do so. A set of subsidies has to be, right, specific to a particular set of technologies or a set of approaches. And so this is kind of the approach that has been chosen in the US for so many different reasons, many of which folks may be aware of. Most of them are political. Okay, so I would say that political constraints suggest that this approach is probably going to continue in the United States. So again, unlike many of our major trading partners, instead of sticks, we're using carrots. And carbon pricing has a low per ton cost relative to these kinds of sector-specific subsidies that we see in the US. Unfortunately, it also has very low feasibility. So it's kind of hard to know what decarbonization policies, if any, will remain under the current administration, right? The administration has already withdrawn or stated its intention to withdraw from the Paris Agreement, and has had certainly a lot of rhetoric about reducing subsidies, although no concrete actions yet, I think, in that regard. But subsidies, once they're here, tend to stick, right? So once you create a subsidy, there's often a significant constituency for that subsidy that's going to lobby really, really hard to keep it in place. So again, I would sort of suspend judgment so far as to whether, right, the carbon capture subsidies are going to continue or not. All right. So as climate policies, what do we think about these approaches from an economic perspective? Well, there are a lot of things to like about subsidies and other things that make them economically inferior to other approaches. So I want to kind of frame that generally for you, and then we're going to talk specifically about 45Q, this dollar per ton subsidy for sequestering CO2, and we're going to think about kind of where it fits in the spectrum relative to pros and cons. So there are really good reasons economically to use subsidies to promote kind of climate-friendly technologies in some instances. So I'll give you a few. One is to subsidize research and development. Why? Because the benefits of research and development of new climate-friendly technologies don't just accrue to the firms that innovate and adopt those technologies. They spill over, right, and they benefit other firms. And because of those positive spillovers to R&D, we're going to tend to get underinvestment in climate-friendly technologies if we just kind of leave that to the market. And so that's one really common economic justification for using subsidies to promote things like technologies that help us address climate change. Another really good reason to use subsidies is in a case where you have learning by doing, which we also have in spades for the climate problem. And that's a case in which many, many firms learn when one firm innovates and adopts a new technology. And again, it's a way of those technologies and those advances sort of spilling over to other firms. And so no individual firm can capture all of the benefits of that kind of innovation and deployment. And so again, there's sort of a really important economic role there for the government to step in and say, hey, we're going to subsidize, right, research and development for these technologies because we know, right, that firms can't capture all of these positive effects. A third really important reason to have subsidies for climate-friendly technologies is cases where you have what we would call kind of network effects or network externalities. And so these would be technologies like electric vehicle charging stations, right? So you have a sort of chicken or an egg problem. Firms think to myself, should I invest, right, if I'm Ford or GM, right, an automobile manufacturer selling cars into the American market? Should I be producing lots of EVs? Well, it kind of depends on how many charging stations are available and what that network looks like, because they're not of much benefit to consumers if they don't have great access to those kinds of charging networks. And again, it doesn't really redound to the benefit of any individual firm enough to make the huge investment in those charging stations unless, right, they know that that network is going to get sufficient, right, for individuals to buy their vehicles. And so again, that's another case, and I would actually put CO2 collection infrastructure on that list as well. Similarly, right, if I install carbon capture, do I have a pipeline, right, of sort of transporting that CO2 to its storage location? And if I build that, right, isn't that just going to benefit a bunch of other firms that want to do the same thing, right? So those kinds of network effects are really important, and it's why we tend to see economists get behind, right, sort of subsidizing those kinds of infrastructure investments. And then something that's less relevant for carbon capture, but certainly for things like renewable electricity and so on, energy efficiency investments, home weatherization, and these other approaches, is that sometimes you have cases where, right, firms or consumers tend to undervalue energy efficiency, right? Maybe there's, if I rent an apartment, I don't pay an electricity bill. It's my landlord that's making the decisions about energy efficient heating or an energy efficient dishwasher. I'm not really paying the energy bills, right? And we get this sort of separation between the person who's making the investment and the person who gets the benefits or bears the costs. And again, in those cases, right, there's really good economic justification for subsidizing technologies in those cases. Okay, so there's a whole list of things or ways in which an economist would say we should be subsidizing technological advancement to reduce, right, the threat from global climate change. On the right, there's a list of things, right, sort of situations or challenges where we think subsidies are probably less effective and likely inefficient relative to something like a carbon price, right, or a different set of approaches. And that would be, right, concerns like, and again, I'm going to try and take each of these concerns and blow them up a little bit when we think about carbon capture in particular, so that we can maybe understand a little bit better why I'm going to advocate for changing the current approach. So subsidies that are less effective and likely inefficient in cases where we start paying firms on a kind of dollar per ton basis to reduce emissions, because that can have counterproductive effects on emissions. And I'm going to get into the sort of technical piece of this in just a minute, but I want you to just think about the fact that when we pay firms to reduce CO2 and we're paying them, say, $85 per ton, it's the firms that produce the most pollution that get the biggest payments. So from an economic perspective, that's kind of at the basis of the critique that I'm going to talk about today with respect to CO2, right? We don't design all subsidies this way, but this particular one, this 45Q subsidy for carbon capture, is designed in exactly that way, right? So it turns out, right, that it's much richer subsidy for, say, a coal-fired power plant than for a gas-fired power plant, because a coal-fired power plant has much bigger CO2 emissions per unit of power generated, and so we're sort of tipping the scale in favor of the dirtier technologies. And in the long run, that's not going to be a good thing for the climate, and it's not a great thing for the economy. Okay, so that's the first downside, and we'll get into the details of that with respect to 45Q in just a minute. Another thing that's challenging about subsidies is that the government has to choose, right? Which technologies do we subsidize? Imagine the horse trading, right, that happens in negotiating something like a big package like the Inflation Reduction Act. How on earth, right, do firms lobby, right, to get their particular technologies, their favorite approaches on that list, right? How do households have a role, right, in thinking about this? In any case, right, the government has to choose a suite of technologies to subsidize, and that can cause challenges in the long run too, right? In the economy, what you'd really like if you set a carbon price is then firms, right, everybody has to compete, right, for ideas about how to, right, reduce emissions, and what you see is the most cost-effective approaches kind of rising to the top, right? So if it's cheaper, for example, for a power plant to increase the share of renewables, right, in generation than it would be to use carbon capture, then it's going to go with renewables. But if I say, hey, there's no subsidy for renewables, but there's a big one for carbon capture, I'm sort of tipping the scales in favor of one technology versus another. So that process is really challenging for the government, right? Kind of picking horses and trying to predict, right, which technologies are going to win out over the long run in particular tends to be a really big challenge. Another challenge with subsidies is that a lot of the dollars that get paid out in subsidies go to recipients that would have made the investments in these technologies even without the government subsidy. So that's not a huge issue for carbon capture, for reasons I'll talk about in a minute, but it's important for a lot of other subsidies. Like think about subsidies for electric vehicles, for example. Those are pretty rich right now. They may go away, depends, right, on whatever is happening in the White House and in discussions with Elon Musk and others, right, in the government. Who have a stake in that question. But I would say that if you think about the subsidy for an EV right now being about $7,500 per year, that's kind of or $7,500 total. That's the maximum subsidy right now in the US for 2025. That's a pretty big chunk of the price of a vehicle, right? And so if I'm paying $7,500 to a household for an EV subsidy because I want to reduce emissions, I would like to be confident that that household would not have purchased that vehicle but for the payment. Because if they were going to purchase the vehicle and then it's like, hey, well, this is great, I'm going to get this incentive too, right? And then they receive the incentive, then you can't really credit the subsidy with purchasing the emissions reductions that it achieves, right? And so what we want to try to avoid in policy is paying money for nothing, right? We want to avoid making payments that don't give us, right, those emissions reductions that we kind of are hoping that the policy is going to give us. Okay, why do I say that's not a huge concern for CCUS? As you'll see in just a few minutes, carbon capture is really interesting among all of the things that we subsidize under the IRA because there really is no market for it but for the government policy. There's very, very few firms out there that would even be considering carbon capture technology except for the fact that the government is making a payment, right? So we don't think we're sort of, making payments to a bunch of firms that would invest anyway in this technology. And you'll see why that is the case in just a couple of minutes. Okay, so for these reasons, it turns out that subsidies tend to be a very expensive way of achieving kind of policy goals with respect to decarbonization in comparison to something like a carbon price. Now, I say that not to say, we should sort of condemn the approach under the IRA or anything like that. Again, a lot of IRA subsidies would fall on that left-hand side, something like an investment tax credit for wind power and so on. So there are many subsidies under the IRA that fall under that list. In addition, right, we have to understand we've got a set of policies in place for the politics that we have in the United States, and right, a very, very, very thin set, if any, of additional options that were on the table and were politically feasible at the time. Okay, so kind of that's a caveat, but it's still, I think, worthwhile to think through on that list, right, for each of these things, would we do it differently if we thought about it, what the incentives actually imply. And so that's what we'll do for carbon capture. Okay. So back to CO2 capture. So this is a picture of me with some of my colleagues. It was during the pandemic. We were touring what is a pilot carbon capture facility at a kind of research campus associated with the University of Texas at Austin, which is the last place that I was a faculty member before coming to Cornell just over the summer. And so that includes my colleagues Andrew Waxman, H.R. Huber Rodriguez, and myself, who did some work on CCUS and local air pollution that Peter mentioned earlier. I'm going to come to that toward the end of the talk today. And then some broader work on the policy design flaws in 45Q, which I'm going to talk about first. And that includes that same team plus some additional graduate students and also Emily Grubert, who's a faculty member at Notre Dame, and Chuck Mason, who's a faculty member at the University of Wyoming. So let's start first with these design flaws in 45Q. So some of these stem from the kind of challenges with approach to subsidies that I mentioned earlier. And others are sort of special that we kind of need to talk a little bit more about. So the first one is that with little private market for CO2 capture, you essentially, once you create this incentive, you kind of have to keep it in place forever in order for firms to keep capturing CO2. And so I'm going to get into some details on that in a minute, but understand that that's very different from subsidizing, say, wind power generation or solar power generation, where the idea is I'm going to subsidize for a while, but right, basically they're producing electrons, which people value, and as long as they can do that for a cost over time that's lower than alternatives like natural gas or coal, those technologies will displace the older, dirtier technologies within electricity generation and eventually, right, sort of stand on their own 2 feet. Carbon capture, very, very different. Again, this is not something, unless they're required to do it, that firms are going to do just because there's sort of a private market for CO2. So we'll talk about that in just a minute. Second group of critiques of the policy come from the fact that it's paid on this dollar per ton basis. Again, so the sort of firms with the highest emissions are going to get the biggest payments. And so we'll talk about that in some detail. And then finally, work that I've just recently published in November with my co-authors suggests that the most common post-combustion carbon capture technology that would be deployed by industrial sector facilities and even power plants in most of the United States generates some significant human health damages, and that those damages are significant enough that we might question, right, whether this is a policy that we would want to choose relative to other alternatives to reducing CO2 emissions in these particular industries. So again, I'll be more specific about that in just a minute. Okay, so let's take this first critique and just kind of dig a little bit deeper on it. So my first critique was, hey, for CO2 capture to continue, I have to make a payment forever. Right? It's why we don't have an investment tax credit, right? Where investment tax credit is the primary way that we're subsidizing, say, the development of wind energy, right? And we do it that way because once you subsidize the construction of the power plant, right, of the kind of the wind facility, the marginal cost of electricity generation with wind is essentially zero, right? Sometimes like the wind doesn't even blow at a time or blows at a time when we don't have high electricity demand, and we're even paying people, right? This happens often in ERCOT, the grid that serves most of the state of Texas, right, to sort of take energy off the grid. We're kind of paying people to use electricity. So it's a really competitive technology once we subsidize that initial investment. Again, with carbon capture, not so, right? So I could subsidize the carbon capture facility, but there's literally no incentive in most places for firms to run that capture facility without some kind of an ongoing payment or a tax, right? Again, my favorite instrument would be a tax, but that's not where we are. Okay, and so that makes it really, really different. So there, is there some private demand? Sure, right? So there's, right, you could have facilities that are, constructing, making green cement, right, embodying CO2 in cement, and so there would be some demand from those kinds of applications. There certainly is demand for using CO2 for enhanced oil recovery, but payments for things like that, first of all, are very low, right? So even in California, where we have a cap and trade program, those prices for CO2 hover around maybe $30 per ton. A payment for CO2 for enhanced oil recovery might be $30 or $40 per ton. And think about how low that is relative to $85 per ton, which is sort of generating all this interest in developing new carbon capture projects. It's just not high enough, and the market will never be big enough, right, for these applications to store the kind of quantities of CO2 that we saw in that first IEA graph, right, in terms of millions of tons of CO2. And so there is, in some places, a private market for this, but it doesn't pay nearly enough to get the kind of deployment that we would envision if you look at kind of US or even global decarbonization goals. So that means that it's not the market that is providing the primary incentive to deploy new CCUS. It is policy. It is $85 per ton payment from the federal government, right? That's why firms might think about investing and are making these investments. So we're creating the market through government policy. That means that if the subsidy stops, I might turn off my capture facility. In fact, I very likely would. So I'll think about why, and then I'll give you an example. And again, the answer is why? Well, because it's costly to run, and if I don't receive an ongoing payment, then there's no reason to do it, right? I'm just incurring a cost with no private benefit to the firm. And so the example that I have, there's not a ton of deployment yet in the United States. So I mentioned 19 active projects. There's only one that's on a power plant. It's a coal-fired power plant, sort of one of 8 generating units in the W.A. Parish plant that's near Houston, Texas. It's one of the country's largest coal-fired power plants. That carbon capture unit, which was heavily subsidized by the DOE, was running for about 3 years. In 2020, it shut down because most of that CO2 that was captured in that plant went to enhanced oil recovery in nearby oil fields, right? That is, the plant was sort of receiving payments based on the price of oil from firms, right, that were out there in the field, right, trying to increase the oil that they're recovering from older wells, right, that were being stimulated with carbon dioxide. And once the price of oil fell during the pandemic in 2020, the firm, right, the W.A. Parish power plant shut off the carbon capture facility. It was no longer economic, right, to run that carbon capture facility with prices being as low as they were during the pandemic. Later on, in September 2023, they started production, started capturing CO2 again, but again, it was purely in response to this price incentive, right, for EOR, or enhanced oil recovery. So we know that firms do this and would do this in response to any kind of incentive for carbon capture, and we certainly think that they would do this in response to the sort of expiry of the subsidy for CCUS. The current 45Q says it's eligible for any plant that starts construction by 2032, and then that firm can receive payments at $85 per ton for 12 consecutive years of operation. Okay, so 12 years could be great, right? Because you could get a lot of carbon capture in 12 years, but what happens after, in year 13 and beyond, right? So that's a big concern for the climate, again, given that this is a very long run problem. So you have this unpleasant trade-off if you're a policymaker. You can choose to extend 45Q beyond the 12-year limit that's currently in the legislation that was passed in 2022 in the IRA. And you can, right, if you extend, you can keep getting these carbon sequestration benefits, or you can not extend it and then you don't, right? Firms that are there, and unfortunately, a more carbon intensive sector that you've created because you incentivized, right, all of these additional emissions that we're giving firms payment, shuts off carbon capture, right, and again begins releasing that to the atmosphere. So that's a big trade-off, and it's a really big challenge. And again, it's very different from the other technologies that we subsidize under the IRA. Okay. So let's take this counterproductive emissions incentives example. This critique, it's important. So what happens when we pay firms a subsidy, right? For every unit of CO2 that I emit, I'm going to get a payment to capture that CO2 before it goes into the atmosphere and bury it deep underground. When I do that, right, I'm paying firms on a dollar per ton basis. I'm reducing their total cost of production and I'm reducing their average cost of production. And so in addition to firms with the highest emissions getting the highest payments, I'm also incentivizing additional production, right? The more I produce, the more payments that I get at $85 per ton. And so existing firms increase their production relative to what they would have without the subsidy, and that eats away at any emissions abatement effects that you're having. So again, this is not to critique CCUS as a technology. So you get a lot of capture with CCUS. So typical post-combustion carbon capture on a power plant or an industrial facility was probably going to capture around 90% of CO2 emissions, right? Or counterfactual CO2 emissions, which is great. But still, that doesn't mean you're going to get a 90% reduction in emissions if you use the subsidy. You're going to get 90% off of, right, the production that happens with the subsidy in place, which is going to be higher than the production you have without the subsidy in place, right? Because we've incentivized this additional production. So the degree to which this happens is really important, right? How important is this sort of extra production effect relative to the reduction in emissions that you get from installing the technology? It's certainly not one for one, right? We're not going to eat up all the emissions reductions that we get, but we're going to eat up some of them. And that's really important to include in sort of modeling going forward, thinking about the effects of this subsidy. It can also happen through indirect effects. So for example, I could be getting a subsidy, right? Well, let me think about it this way. So we could have a really kind of pure, easy question of, do we reduce emission if we put kind of additional wind and solar generation into an electric grid? And the answer would be yes, right? We're going to get some emissions reductions. But when we do that, we reduce the cost of electricity generation. And people aren't paying for electrons from wind and solar, right? They're just paying for electrons. And so when we reduce the cost of electricity, we increase the demand for electricity. And then emissions can go up across the grid because some of those resources producing, right, to meet that additional demand that's created by the subsidy for wind and solar are going to be satisfied by electrons generated with natural gas or coal, right? Right, again, depending on what these alternatives are that are on the grid. So in a similar way, right, if I'm subsidizing carbon capture, I can get these kind of indirect effects, especially in the power sector, where I get some increase in emissions associated with, right, having paid firms to reduce their emissions. And so for those two reasons, we got to be really careful in thinking about what the savings, right, what the emission savings actually are from this subsidy. And again, it's not one for one. Another thing that happens over time is that you change the composition of the industry. So if I'm paying, right, I've got a policy in place paying $85 per ton to all these firms that are making, petrochemicals or refining oil into gasoline and so on and so forth. I've kind of created an incentive that makes it so the firms that, if I had installed instead a carbon tax, some firms would have had to exit the industry. And those firms would have been the highest emitting firms, right? The firms for which emissions reductions would have been just too difficult, right? So they would tend to exit the industry over time. And cleaner firms would be incentivized to enter. Under the subsidy, the opposite happens, right? Because we're paying firms for emissions, right? So we're going to draw in firms that have higher emissions, and we're going to keep from exiting, right, the firms that have the lower emissions. So we sort of set ourselves on a path, right, where we have sort of a higher carbon intensity, emissions intensity, than we would otherwise have without the subsidy. So again, because of these dynamic effects, you want to be real careful in thinking about how much emissions reduction we're actually going to get in the long run. So over time, it matters if capture is not 100%, which it's not. If there's a large energy penalty, something I haven't mentioned is that it takes energy to run the carbon capture unit. The estimates there, probably it's reasonable to assume 15 to 30% increase, right, in energy generation just to run the carbon capture unit. So it depends on that as well. And then it depends on, right, these kind of entry and exit dynamics. So this is really important. It also matters for the fiscal costs of the subsidy, right? So that it's, right, how attractive this is, right? How many firms we get in the industry that are taking the payment and so on can make a big difference to the bottom line of how much it will cost. And then under some conditions, right, depending on the scenarios that you look at, we can even end up with emissions higher than they would have been in the absence of the subsidy. And that is not the goal, right? when we subsidize carbon capture or any climate-friendly technology, what we expect to see is a reduction in emissions over time. And if we can't be certain that we're going to get that, it's kind of not meeting the first criterion for the policy, right? Which is that it should be effective in achieving its goal, in addition to being cost effective. All right. So does this matter for the US? It's really hard to tell because, as I mentioned, we don't have a lot of deployment. So I'm an applied microeconomist. I do a lot of work that's retrospective, looking at data, right, on things that have happened under different policy changes over time. That is just not a luxury that we have with respect to carbon capture right now in the US economy because there's just not enough adoption of this technology to really look at it in that light. So almost everything we're doing, right, is going to be forward-looking, prospective, modeling, kind of making our best guess as to what's likely to happen based on some of the theory that we just kind of went through, right? What we think might happen given the incentive structure. So Emily Grubert, who's an engineer at Notre Dame, has done some work with her group where she says, hey, what if we look at the US power sector? What do we think is going to happen to emissions, right? So this is in billions of tons of CO2 equivalent on the vertical axis. And then this is time passing from 2020 to 2050 over here on the horizontal axis. And then she has a whole bunch of scenarios that they looked at. I won't describe each of them in detail. But the big thing to notice here is, again, right, this subsidy expires in 12 years from, right, when the firms begin to take the subsidy, because they can have 12 continuous years of subsidy. And so the big thing to notice is that from any scenario that includes the carbon capture subsidy, you see this big jump up in emissions after the subsidy expires, right? And that's not that long from now, right? If a firm starts taking the payment this year, right, that's just in 2032 you would expect to see, right, that big jump up in emissions. So again, I just remind you, when we're paying on a per ton basis, right, at $85 per ton, that tells me, right, that 45Q is giving about $100 per megawatt hour generated for a coal plant and about $40 per megawatt hour generated for gas. Gas being cleaner than coal is not exactly the incentive, right, we want to be sort of projecting out there into the power market in the US. Okay, if you look anecdotally, right, at the kind of industry press, you see firms saying things like, hey, we were thinking about mothballing this coal plant, but now we're thinking about maybe, right, delaying retirement of this plant because we can get these payments if we install the carbon capture unit. And again, that makes maybe some sense for a coal plant, right, if it's going to be getting $100 per megawatt hour in the subsidy. And so that's important to look at that anecdotal conversation that's happening out there as well, because it's consistent, right, with what the modeling would suggest. Now, I would say, as a caveat, that most analyses suggest that CCUS is probably not going to play a huge role in the US power sector for decarbonization, right? It's much, much cheaper in most instances for firms to kind of use more wind and solar and, right, take other approaches, battery storage, demand management, and this kind of thing. But still, right, it could potentially be important, which is what her study shows. And also, we don't have any equivalent analysis of the industrial sector. But we would expect exactly that same pattern, right? We might get some initial kind of CO2 sequestration early on, and then as soon as the subsidy expires, right, we would expect that to go right back up. Okay, the third critique is this critique related to human health damages. And so let me tell you a little bit about this. So, you know, as background, when firms are emitting CO2, it's usually a result of combusting some kind of fuel. And so that generates other air pollutants as well, right? Not just carbon dioxide. And so there's kind of a good story with CCUS and a bad story with CCUS with respect to other pollutants. The good story is that we would expect emissions of things like sulfur dioxide, nitrogen oxides, and kind of direct emissions of fine particulate matter to fall or stay stable if firms install carbon capture technology on power plants, refineries, right, and other industrial facilities. And so that's a good story, and in fact, something that we model in our paper. And it's what it means is that especially for coal plants, almost unequivocally, there's a good public health story from carbon capture, right? Which is, okay, I sequester a bunch of CO2, and that, right, doesn't create climate damages. And I also reduce probably sulfur dioxide emissions, nitrogen oxide emissions, and maybe some other stuff as well. So that's great. Although, again, not relative to plant closure. So if the subsidy keeps a coal plant in the market that was going to exit, right, in favor of some other form of generation, I can't really count that as a win for public health, right, relative to other technologies. Okay, the trade-off, though, is that post-combustion CCUS using amines, which is the kind of most common approach that would be adopted by many US facilities that use post-combustion technology, raises ammonia emissions. And these additional ammonia emissions, as sort of precursors, they create sort of the conditions for formation of secondary fine particulate matter. And it turns out that the human health effects of those is really quite significant. And so remember, again, 45Q pays firms on a per ton basis. For every unit of CO2 that I emit, I'm going to get a payment of $85 per ton. And so in the same way that that incentivizes firms that have high emissions of CO2, it also is going to tend to incentivize firms that have high emissions of these co-pollutants, right, that generate either public health benefits or public health damages. And so the study that we do focuses on the kind of Gulf Coast region in the United States. Why do we focus on that region? Because it is a massive agglomeration of the kinds of facilities that are already deploying and in the future are likely to deploy much more this technology, carbon capture. So we look at power plants, although that may play a fairly small role. This technology may play a fairly small role in the power sector. And then importantly, we look at these industrial facilities, and that's what I'm mapping, kind of the effects of the industrial facilities installing CO2 capture in this region is what's mapped over here at the left. And this is just perhaps the world's largest agglomeration of these kinds of facilities. Again, petrochemicals, so refineries, petrochemicals, LNG export facilities, right? Lots and lots of these high-emitting firms. And also some of the best storage opportunities for CO2, both in offshore saline aquifers, in some cases onshore as well, and also additional sort of existing CO2 pipeline kind of collection networks. So there's sort of a kind of perfect storm, right, of conditions for adoption along with that $85 per ton subsidy in this region, okay? All right, so what I want you to do first is look at these graphs on the right. So the graphs on the right come from our analysis. Again, there's not a lot of this adoption of this technology in the United States, but this facility, the Petronova facility near Houston, Texas, on a big coal-fired power plant there, was in operation right from this period here, it looks like about 2017 to 2020. So in this period, kind of between the dotted left-hand vertical line and the red vertical line in each of these boxes. And what I mentioned earlier is, right, first of all, what do we see in CO2 emissions from that facility when it installs and begins running the capture unit? Well, you see this really big dramatic drop, which is exactly what you want, right? That's what you're paying for. You want the firms to reduce CO2 emissions, right, so they're not generating climate damages. So that's a good story for carbon capture. The story for direct emissions of fine particulate matter is pretty stable, right? Not really, no change there relative to what we would expect. And the dotted line is what we would expect in our simulation, kind of without the carbon capture unit installed. So you're going to kind of compare what happened during this period between the two vertical lines, between the dotted line and the solid line. Not much difference there, right, for PM 2.5 direct emissions. A big drop in SO2 emissions, so sulfur dioxide is really important, right, sort of potential to damage public health, and that, again, this is a coal plant, so the emissions would have remained quite high, right, without the capture unit, but you see that come down when the capture unit is installed and running. And then we don't see much change, a lot of volatility, but not much change that we could attribute to carbon capture in emissions of NOx or nitrogen oxides. Okay, so that's all kind of what we would expect given what we know about this technology. Here's the thing that we might be worried about, right? The one thing where the solid line, right, our kind of the treatment of like turning the capture unit on resulted in increased emissions very clearly is for this pollutant ammonia that I mentioned earlier. And we do see those emissions go up quite a bit, right, during the time that the capture unit was in operation. That unit actually went back into operation at the end of 2023. So I presumably, right, we're still in the same boat with respect to ammonia emissions there. So what we do is we take that and a whole bunch of other information about what's likely to happen to these pollutants when it's installed, when the carbon capture technology is installed on many different kinds of plants that are present in this region as a whole, including, again, mostly industrial facilities, but also some power plants. And we take what we know, right, we push that through, we sort of say, okay, given the cost of adoption in each of these facilities, and given the $85 per ton benefit to firms, who's likely to adopt, and what's likely to happen to their air pollution emissions? And we push that through sort of an integrated assessment model, which is the same model that the US EPA uses when it sets regulations for air quality, to understand kind of what's going to happen to human health on a county-by-county basis. That's what the shading, the kind of heat map here is. These are counties, right? So this county right here where Houston is, that's Harris County. That's the darkest red. And so you can see the states here of Texas, Louisiana, and most of the air quality effects of changes in this technology at the facilities in the database are going to happen in these states that we've mapped here. And so what do you see, right? This is sort of basically just the change in premature deaths that occur among the populations in these counties from from emissions changes due to carbon capture that happen in these different locations in the region. And what you can see is anything that's in this red range, is an increase in premature death from emissions related to the fact that these additional ammonia is generating new kind of fine particulate matter that's causing increased cardiovascular and respiratory distress and these kinds of things. And anything that's in the blue is kind of a savings in this regard, sort of averted human health death, averted premature deaths because we've installed carbon capture. And so you can see that it's highly variable, So these are many different kinds of industrial facilities. There are some places, some counties here where we get kind of reductions in deaths from these firms adopting carbon capture, counties in Louisiana. But over here, especially around Houston, around New Orleans, around Dallas, San Antonio, some of the large population centers, what we see is on net, when we adopt carbon capture technology, we get some benefits, but the costs are greater than the benefits. That is, you get more kind of increased deaths from adopting the technology than you do averted deaths from adopting the technology. And on the whole, that's really unfortunate for this technology because these communities are also communities that are sort of typically Black and brown communities that already are exposed to a really significant kind of cumulative exposure to air pollution. And so what we're doing is creating through this technology and subsidizing this technology a trade-off between local harms on net and global benefits. And in fact, when we do this, so this is for power plants. You can see the story is really quite different. For the vast majority of power plants, for all coal plants, and for the vast majority of natural gas plants, actually the story is really quite positive. But it turns out these excess damages in the Houston area and around New Orleans and Baton Rouge are so large that on average, the effect of adopting in the region carbon capture on power plants is negative. So that tells us from a regulatory perspective where the plant is, what the technology is that it's using. All these things are very important, and you would want to account in permitting for these differences across plants and what the human health damages are likely to be. So I won't, this is a lot of numbers to go through. I'll sort of just put it up there, but maybe just talk to you about what it was that we did here. So we can show very easily that on average, the climate benefits of deploying this technology are well in excess of the human health damages that are happening because of this increase in ammonia emissions. It's just that locally, that's not where the climate benefits accrue. The climate benefits accrue globally, and then the costs in terms of human health damages occur in very, very localized manner. And so you're creating through this technology a set of trade-offs, again, that's really difficult from a policy perspective, which is are we comfortable sort of taking this kind of human health losses in order to achieve the climate benefits. And that's a tough call, from a policy and a stakeholder's perspective. Okay, so before I take questions, which I'm happy to do in just a couple of minutes, I'll mention that we're actually very optimistic that these flaws that we've identified in the way that we're incentivizing carbon capture in the United States can be fixed. Okay, and so the purpose of one of the articles that we've written is to say, how would you do this differently and avert some of these downsides? And so one way that you would do this, you could switch to something like what we do for wind and solar, which is an investment tax credit, but you would still have to add on a carbon tax or some kind of carbon price on uncontrolled emissions. Why? Because again, if I incentivize the construction of the plant, and I don't have some ongoing reason to continuing capture carbon dioxide, then the firm will not run the plant, So it's very different from the wind and solar situation, okay, in that way. So you could switch to an ITC, and then you could have a carbon tax on top of that for uncontrolled emissions, and that would work. Another thing that you could do to make things better would be to pay firms on a kind of per unit of production basis instead of a per unit of emissions basis. And that would help to equalize, that incentive that's so uneven, for example, between natural gas plants and coal-fired power plants, where we've got $40 per ton for gas plants and $100 per ton for coal plants. Similarly, you would have these differentials in the industrial sector that reward, under the current structure, the dirtier firms, whereas if we switched to a kind of something that's based on the units that you're producing, we could correct that. We wouldn't have such an imbalance. Another thing that you could do is you could continue to pay firms $85 per ton or wherever we end up, right, with the subsidy for sort of capturing CO2. And you could have a carbon tax on their uncontrolled emissions, okay? So that would be better than the current approach. And then finally, right, in almost any of these cases, right, you would still need to directly address, if you want to solve that local human health problem, you'd have to directly address those ammonia emissions from the post-combustion technology through some other policy, right? You could, require, just regulate those effects directly. You could tax ammonia, right? There's different ways that you could do that, but it's definitely something that's sort of separable from, right, what it is that we're doing for CO2. So just to sum up, this post-combustion carbon capture on point sources is a really important, excuse me, climate change mitigation technology. It's essential in many models for reaching aggressive decarbonization goals at the state level, at the federal level, at the international level. In the United States, the main thing that we do right now to incentivize the development and deployment of this technology is we subsidize it on a dollar per ton basis under this tax credit policy. And this has some really critical design flaws if what we're trying to do is reduce CO2 emissions and do so without increasing local air pollution emissions and damaging local human health. And so it's really important to know that the ways that we choose to decarbonize are actually important, right? It's not enough to say, hey, it's awesome that we got the Inflation Reduction Act, this whole package of subsidies. My reflection on that is that many parts of that are awesome, right? But it's still, right, it kind of helps us if we can kind of go through and think about these separate incentives and how some of them are different from each other and why we might want to take a different approach, at least in some cases, okay? And I'm happy to take questions. Yeah, sure. Sure, yeah, if folks have questions, just raise your hand and then Peter can maybe walk around with the mic. It looks like you got one in the back, oh, and over here too. Three.
Hi, thank you. That was so interesting. I was wondering, and sorry if I missed this, but why does the subsidy only last 12 years? Like, why that number?
It's a great question. My sense is that, right, subsidies also, right, so a tax, I'm collecting revenue. Subsidy, I have to pay out. And so the way they designed the bill, right, was they had to meet budget constraints, right? They had to think about how much the whole thing was going to cost. And so both the level and the length, right, of the incentive were part of that grand bargain, right? That's sort of struck about, okay, well, how you know, and if I was going to make this longer, then I'd have to reduce something someplace else, and so on. And it is really challenging. So there's some really good studies of the IRA kind of post-passage that suggest that not just for the carbon capture subsidy, for others, they've just been more appealing to households and firms than the initial kind of pre-passage modeling suggested. And so that means the fiscal costs of this approach are higher than we would have thought back in 2022 when the IRA was planned. And again, it makes me worry that the 12 years, right, is sort of less likely to be extended in a world where the whole package is more expensive than we thought it was going to be, in addition to being kind of politically vulnerable under the current administration. Costs should continue to increase, that's right. Yeah, it's a great question.
Hi, thank you so much. I was wondering if carbon capture infrastructure was in a place and it was making the air quality worse, would the local people be told that that was a risk they could experience?
So it's a great question. And actually we have, this work that I mentioned was funded by the Alfred P. Sloan Foundation. And so Sloan has funded for us some kind of outreach events where we actually have one that's going to take place in a couple weeks in Beaumont, Texas, which is kind of right there in the region. And then another that's going to take place in DC, where we're really trying to work to kind of communicate this to people. I think, you know, generally the answer is not so well, right? I think it's really tough to assume that people know. Ammonia is something, right, that has a significant smell associated with it, so maybe, right? But really understanding, right, this link between ammonia and fine PM and then how fine PM affects health and so on, I think that's a big stretch. And so again, right, it's another reason why we might worry about that trade-off. Yeah, it's a good question. Anyway. I can hear you. Why don't we, let's try. You want to just try speaking loud? Yeah, let's try that. Go ahead.
So 45Q, obviously, it like I can't speak right now, sorry.
That's fine.
But like higher emissions equals like
Sure.
Well, like even like with like the EVs, 7,500 for every EV that is purchased.
Yeah.
And like that's been very successful in like the
Yeah.
purchasing process of EVs. So what
Yeah.
are your thoughts?
Yeah, no, I think it's a great question. So I'd kind of come back to some of the suggestions at the end, and you're right to think about like, how do we fix this problem that we're sort of giving the biggest payments to the firms with the biggest emissions, right? That's exactly what we don't want to do, both in a dynamic setting and also kind of in the short run. And so anything we can do to kind of tweak that, right, can be helpful. And again, you know, you never let the perfect be the enemy of the good, right? I would take some small changes around the margins over nothing, because it's all going to help. And I think the kind of most important change you could think about would be this idea of let's kind of do it on the basis of some like emissions rate or emissions, you know, per unit of production. That would at least get us to, right, we're going to kind of give the same payment for, right, a coal-fired power plant, or a smaller payment for a coal-fired power plant than for gas. Whereas right now, right, it's the opposite of that. So I think that's sort of the simplest tweak that you could make in the short run. Whether politically that would be on the table, I think is an open question. You know, maybe, right? Sort of depends on, right, how coal or gas might be favored relative to each other in the political process. And that's a tough call, I think. Yeah, good question. Yeah, go ahead.
What's your perspective on the EU's carbon border adjustment mechanism from like a policy perspective?
I love the carbon border adjustment mechanism. I mean, I know, again, obviously it's going to come under fire a lot in the kind of current dialogue, because the dialogue that we're having links very tightly trade and environmental policy, in particular climate policy, with the current US administration having a pretty, you know, strident view on both of those matters. But basically, sort of for folks who might not be aware, so the EU emissions trading system is a carbon pricing system that applies to all countries in the EU, but in things like air travel, for example, if a US carrier, like say Delta, wants to land a plane in Paris, it has to pay the emissions fees, right, for the emissions from that flight, even though it's a US carrier and not a European carrier. And that question of whether that was going to be true or not went all the way to the World Trade Organization. There was some dispute over that. And right, the EU ETS won that dispute. And so even right, so, and the idea is, as long as we're sort of treating everybody the same, those kinds of challenges, right, those kinds of environmental, you know, kind of amendments to trade, right, or sort of constraints on trade, it turns out right now it seemed like they can stand up kind of in that international setting. And so the EU is starting now, will soon be implementing something called a carbon border adjustment mechanism, which says that, hey, it's not just air travel, but any goods, right, that are kind of being sold in the EU market, right, in countries that are part of this emissions trading system, they're going to be taxing those goods on the basis of the embodied CO2 that's right in from the production of those goods. And that, of course, means we don't have a carbon pricing policy in the United States, right? And so basically anything that's below that EU carbon price, right, we're at zero, right? But, you know, if I'm in Canada, let's say it's, right, $50 Canadian, right, we're going to sort of tax the embodied carbon that's kind of below that price. And so why do I love that? I love that because it's one of a very small number of ways of trying to sort of improve that collective action, right, that is happening on behalf of the global climate, with a very strong kind of economic, you know, kind of cost effectiveness bent. And so I'm a big fan. I think most economists are fans. Whether US policymakers will be fans, right, is a different matter. But in a way, right, as long as it doesn't violate, you know, kind of trade agreements under the WTO, I don't think that we're going to have much of a choice. And that could provide a pretty strong incentive, especially for multinational firms that are selling into many different markets, right? They don't want to make kind of different cars, right, to sort of sell here versus there and so on. So I think it could actually be quite a strong instrument, and we'll have to wait and see. But it's definitely a space to watch. Yeah. Yeah.
Hi, I'm curious what regulatory power the EPA has as an agency over carbon capture.
Well, that's very much in flux. So the EPA plays an important role in many ways. So the question is, right, what role the EPA has in terms of thinking about regulating carbon capture. So toward the very end of the Biden administration, it passed an important set of greenhouse gas emission standards for power plants. And in that set of standards, carbon capture was basically the compliance mechanism for gas plants and coal plants. Right, so meaning that really gas plants and coal plants going forward would not be able to operate and have a permit to operate in the US, right, from the EPA unless they installed this technology, right? Again, the timeline was different, and right, existing plants versus new plants was different, but that's basic idea. So in that way, they stood to really would have provided a really significant incentive. So that particular rule would have been very important. And actually, my co-authors and I on the public health paper had a lot of discussion with them. And actually, we sort of, some of what they were doing was influenced by what we were talking about with respect to the plants in our sample. And that was a very productive conversation. That rule is very likely to be one of the first that's going to be repealed by the Trump administration's EPA. And so whether it will actually take effect, and if so, would it be now, or would it be 5 years from now or 8 years from now, it's hard to say. But that's basically the kind of channel through which EPA could influence the adoption of this technology, would be either by regulating the air pollution, CO2 and other air pollutant emissions directly, for different sectors, or through, kind of permitting, even the ammonia problem, could be solved, through permitting of individual plants. It's a great question. Yeah, you have it in the middle.
So in most people, it's really hard to make the subsidy system better.
Yeah.
It involved a carbon tax. Isn't that then what is the purpose of the subsidy if we have the tax? Does it
Yeah.
still help at all?
Yeah.
Because I thought it was more of a way out of the tax.
It's a great question. So what I would say is, you're right. You could say, oh, geez, Olmstead, if all the ideas have a carbon tax, we're never going to get any of those ideas. So you could have a political problem with what I'm suggesting. The one that doesn't is the one, that I mentioned in response to the question over there, which is, let's just switch it and not pay it on the basis of emissions, but pay it on the basis of production or something like that. But you're right. Most of the others would say, okay, let's do an investment tax credit and a carbon tax, or continue to pay the subsidy but put a tax on uncontrolled emissions. The answer is that obviously it's not cost effective to do that, If you continue to have the subsidy, it's still going to be more costly. The fiscal implications are there. I think what we're thinking about is kind of what's feasible, kind of in the current political environment. And just a straight out carbon tax would be better than any of those things, It's just that that's very unlikely. Would firms rather have a carbon tax on uncontrolled emissions and the subsidy 45Q than repeal 45Q? Probably, Because again, emissions, they're going to control 90% of those, On balance, they probably would take that relative to no subsidy at all. So that's kind of the basis on which we're kind of describing these alternatives is, okay, what's something that's likely to galvanize some support from the industry, which you kind of need, especially in the current administration, but also still going to achieve the goal of reducing emissions, And you don't want to be paying the subsidy if you're not reducing emissions. So that's really important. Yeah, in the back.
So you mentioned that when subsidies are in place, they're rarely repealed because people or companies benefit and will lobby for the cuts. I was wondering if this happened in the front end as well. In short, when 45Q came about in the first place, was it lobbied by oil and gas from the get-go or no?
Oh, that's a great question. I don't have a great sense for kind of what was happening in 2015 when it was created, but in 2018, for sure, the oil and gas industry was on board with that. I mean, some of the same technologies, if you think about it, it's not even just, a story about, well, this is going to kind of perpetuate the use of oil and gas in electricity generation or anything like that, but a lot of the same technologies that you use to get oil and gas out of the ground are the same sort of skills, technologies, labor force, capital investment, drilling rigs, and so on that you use to put CO2 back into the ground. So in a way, whether this is a story about ownership of natural resources and, kind of lobbying on the behalf of coal and gas, it's literally, it's sort of another form of bread and butter, for these industries to be engaging in carbon capture. And so you do see, firms that support it even just on that basis. And so I think for sure, that they play a role in that. Yeah. Yeah, how about in front?
Going back to the more earlier of the slides, you talked about how the US chooses a different route in terms of controlling carbon emissions than the rest of the world, and in choosing subsidies as opposed to taxes and carbon prices. Could you elaborate on why that is?
How do we get carrots instead of sticks when other countries are choosing sticks over carrots? Yeah, it's a great question. What I would say is, first, I'll kind of back off a little bit on making that distinction, because every one of those countries, including the European countries that are covered by the EU ETS, also have subsidies in place, So it's a belt and suspenders kind of approach usually. If we go with carbon pricing, we still often have some, sort of subsidies in place, but it's still a kind of a notable difference between us and our kind of peers, a kind of peer economies with which we're trading lots of goods and services. And so it's worth it to think about why that's the case. I think in large part, that's a function, so again, like the last time we kind of came to the brink on carbon pricing at the federal level was 2010. And that was a setting in which the Obama administration, they had just passed the ACA, the Affordable Care Act, which, as you might recall, or even if you didn't recall it, you might know from news ever since then, was a huge political challenge. And so then they went sort of after climate policy next, and they didn't get there, right? So they didn't get what they set out to get. And since then, anything that started in the Congress, despite, right, there's a Republican climate coalition, and there's all this, there are small efforts. Even some of those proposals I showed earlier, right, on the carbon capture, the 45Q graph by Bernie Sanders and others, nothing that kind of generates the kind of support that, that subsidies do. That's A. B, the courts have changed a lot in what they allow. So the question earlier, right, was about what EPA can do. So it used to be the case that administrative agencies like the EPA had a fair amount of control over kind of where to set standards and how to, whether to regulate greenhouse gas emissions and how from power plants and other facilities. And the courts, for a variety of reasons that we don't have time to get into today, have kind of blocked that path. Right? So the Supreme Court in particular is much less likely to defer to agencies on really important questions like that than they were in the past. And so things that happened under the Obama administration after that failure in 2010, there was a lot of stuff that happened in terms of administrative rulemaking. So the Clean Power Plan, new, kind of corporate average fuel economy standards for vehicles that really kind of incentivized the increase in production in EVs and other emissions, lower emissions technologies and so on, that have faced really big challenges in the courts and then been kind of overturned or repealed. And so political situation in the Congress makes it very difficult to coalesce around sticks. The courts make it very difficult to do other things, right, sort of through the agencies. And so what the administration, the Biden administration, is left with is the option to basically enact climate policy through what's called the budget reconciliation process, which is basically, hey, I'm setting the budget, right, or I'm working with the Congress to set the budget, so why don't we spend a bunch of money to incentivize stuff, right? We're gonna kind of put that in the budget instead of, right, doing it through policy. And I think that's how we ended up, kind of in a nutshell where we are, and those same constraints just haven't been the case, right? That kind of combination, that kind of deadly combination of constraints for climate policy, I think haven't been the case in many of our kind of major trading partners. So I know it's a long answer and a challenging question.
I think we should end it there. So thank Sheila again.